Let's look at question B from the multiple choice in the MAT 2017. We're given another function now. Function f of x is 9 cos to the 4x minus 12 cos squared x plus 7. And we're asked, what is the minimum value of this function? So a couple of things to note is, the first thing you might spot is, okay, we've got only even powers of cos. And that's really nice because for a start, this would be a quartic and we wouldn't really know what to do with that. But we can treat this as just a quadratic in cos squared, because this is 1 cos squared here, and this is a cos squared squared. So it's just a quadratic with cos squared. We have to be careful when we think about the minimum value, because of a quadratic, it's either one of these ones, the sad face, or one of these ones, the happy face. How do we know which one this one is? Well, it's a positive coefficient in front of the cos squared term. So we know it's going to be one of our happy faces. So it is going to have a minimum. So the minimum could be at this point. There are two other points that it could be at that we have to be careful. This number, the value we sub in, the cos squared, can only take certain values. Think of the graph of cos of x. It ranges between -1 and 1. The graph of cos squared, therefore, ranges between 0 and 1. So this number can only actually take values between 0 and 1. So it may be that minimum is outside of this range. So we have to make sure we check the endpoints too. But first, let's do that. Let's treat this as a quadratic in cos. So I'm going to let c be a quadratic in cos squared. So I'm going to let c be cos squared. And then what do I have? Well, I can write f of x as 9c squared minus 12c plus 7. Looking at this quadratic, I want to find its minimum value. So I can do this, for example, by differentiating. I know it's a happy face. As I said, it's a quadratic curve with positive c squared coefficient, so it will have a minimum. So I can do this by differentiation, for example. I know that will be the minimum. So let's go ahead. F dash gives me 18c from here, minus 12. And I know that minimum will be when that equals to 0. Well, what does that give me? Simply that c is 2/3. Or in other words, cos squared x is 2/3. Okay, now that's good, because cos squared x can indeed take the value 2/3. If I'd have got here cos squared x was -1/3, say c came out to have to be -2/3 from here, well, we know that wouldn't be possible. So we would know that this minimum was not within the valid range. But here it is. When cos squared x takes this value, the minimum point occurs. So that's good, and we can plough ahead. As I said, it's possible. Cos squared x is in that range. So 2/3 lies within there. So we can plough ahead. Let's substitute this value back into f. And what do we get? Well, it was 9c squared minus 12c plus 7. So working this out, I've got 9 lots of 4 over 9, it's 4, minus 12 over 3 is 4, times 2 is -8, plus 7, which just turns out to be 3. So I can actually conclude, if I look back up at the options, 3 is the smallest. So I actually know the answer is already A. So we can conclude the answer is A. However, I will write a note to say that it was also possible the minimum could have been at an endpoint. So cos squared of x could have been at 0 or 1. Here we knew it wasn't, because we knew the minimum was at 2/3, which was within the range. So we were okay. And also, we needn't have tested it because 3 was the smallest option anyway. So we knew the answer was going to be A.